All right, well, I want to welcome everyone to What is True with Residential HVAC Design and Commissioning. What standards apply? This course is brought to you by the GreenHome Institute. The GreenHome Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. I will be your moderator today. My name is Brett Little, and I am the program manager here. Like all of our courses, this one is approved for multiple continuing education units, as well as GAHI's Certified Green Home Professional in the health and energy pillars, as well as AIA Health, Welfare, and Safety, which may make it applicable to your state-based design or contractor license. Before we get going, we want to do another member shout out. At this point, we want to recognize our longtime members, Habitat for Humanity, Kent County. They've got a job for you. We need your help giving people a hand up, not a handout. Habitat Kent partners with home builders to build or rehab all LEED certified projects, soon to be all electric. They just completed their first all electric home. So we would really like to see someone there take this position and keep that going. And you know, GHI members are doing amazing things, and you can do these things too. You can become a member today, get instant access to all of our webinars, both on demand and live, no registration, all the CEUs you want, and many other benefits. So I hope you'll consider checking that out. And also, we've got a new membership benefit alert. And so 25% off Aware air quality monitors for our members. You can get more than one, and whichever one you want. So sign up again today and check that out over at Aware. And before we get started, I want to thank one of our top tier sponsors, April Air. Help your clients stay healthy. Humidity control, temperature control, air purity. Water efficient humidification is a win for both health and water conservation. Energy efficient dehumidification pairs with right-sized heat pumps can keep the air feeling cool and set higher points in your AC potentially to save energy. MERV 13 filtration or higher captures particulates of growing concerns such as airborne viruses, PM 2.5 that is getting into our house now from wildfire smoke, unfortunately, VOCs, dust, and more. And also radon, second cause of lung cancer after smoking. Paired with it, it's a 1-2 punch. We have homes tested now that we've been testing in areas that the EPA say don't have radon issues. They do. It's happening all over the place. So make sure you're getting tested. Make sure you're installing April Air radon systems on your next build or retrofit to help protect the health of yourself and your clients. You can learn about this and many other healthy home products at April Air. That's AIRE.com. And thanks to our second tier sponsors, Enertech, who have GeoComfort and Hydron module. Geothermal ground source heat pump systems, you cannot deny, are the most efficient systems on the planet, and they're especially useful for large projects, large neighborhood scale projects in old homes that are very hard to retrofit to help you get to all electric net zero energy. And I think any minute now, could be right now, there's going to be new legislation that's going to take these and give you a 30% tax credit through the next 10 years. And it may even come up off the top, I'm not sure, but keep making sure to watch that. Lots of benefits. All right, so enough from me. I want to hand it off to our speakers today, who I'm super excited to have on. And I think I just want to preface this by saying, what we're finding is, especially if you're doing green building projects or just want to have a successful sustainability project, more and more the shell, you know, we've got that figured out, but the heating and cooling systems, especially for getting to net zeros, low carbon, and health, it can make or break these green building projects. And we've seen so many failures now, and we've seen so many great opportunities of new innovation if we can get the HVAC right and convince them that this is a better way to design these systems. So that's why I'm excited to have these conversations. Jeremy, you know, I first met him when he came up to one of my presentations in 2019, the old days, that felt like 10 years ago. And I don't know why he came all the way up to see me talk, because he knows a lot more than me, but I appreciated him coming to one of our lead courses, and I was glad to meet him there and have his value added to class. So I'm excited to be sitting in one of his classes now. And Paul, we've always known Paul for a very long time, and I think while he hasn't been leading one of our events. He helped kickstart the first ever online lead Green Raider training, which has now been happening quite a bit. So we're super thankful to Paul and his previous work with us and being back here today. So with that, I'll let you two introduce yourselves more in your organizations, and thanks for joining us, and take it from there.
So I'll introduce myself first, because Jeremy will take over after this. So myself, Paul Yankee. I get to wear a couple hats today with my partner Jeremy Begley, co-founder of HVAC Design Partners. I'll let him do a fuller introduction of us. But I'm also the president and second generation for Green Building Consulting, a high performance consulting and rating company that gets to play with buildings across the country. We're actually in 17 states, done over 800 certifications of green programs and tens of thousands of units of residential certifications and HERS scores and whatnot. Honestly, we in both of our companies, and this is where I've tried to stay in this in my line, is where you think of ourselves as the high performance building coaches, and our jobs are to help these buildings and all the people and the professionals that are dedicated to making the buildings better, help them build better buildings in any way we can. So we're going to provide you the tools to do that. So hopefully we'll be able to do that too for you today.
So hi everyone. My name is Jeremy Begley. As Paul stated, I'm one of the co-founders of HVAC Design Partners. I've been in the high performance building world for about 15 years now. During that journey, I met Paul. I did a lot of subcontracting work for his company, Green Building Consulting. There came a point in time where we started seeing a real need for HVAC design from a third party in the green building world, because like he alluded to and like Brett alluded to, it is the missing link in high performance. It's the one thing that really, from my own personal experience, that the rating world and the home performance world, which is where I got my start, home performance, didn't really give you a lot of training because they always left that to the HVAC world, and they were kind of scared to interfere. And that's sort of a little bit of the history of the ResNet 310 certification that we're going to be certification pathway that we're going to be talking about, that can be used for commissioning. It came about because Energy Star saw for years and years and years that HVAC installed in Energy Star homes was the weakest link, and a lot of times a otherwise great home was being affected by installation defects from the HVAC system that weren't vetted out at the final inspection. So we were seeing the same exact thing. So we really started scrutinizing the designs, and we found that with my experience in home performance, and I had been doing load calculations. I worked in the HVAC industry for a little bit. I worked in the test and balance industry for a little bit. So I was super familiar with that side of things. It just became a viable business opportunity for us. And one day Paul was like, I'm sick of giving you all this free work. Why don't we make this an actual business where I can benefit from it too? So that's sort of where HVAC Design Partners came from. Under that umbrella, we offer residential and light commercial HVAC design services, test and balance and functional testing, and full commissioning. Light commercial, we usually talk about 20 tons and under. Is usually where we play at when it comes in the light commercial world. And then of course, anything residential, super custom, super simple, whatever, block load calculations, any kind of commissioning, testing, anything like that falls into the scope of what we do. So today we're here to talk about HVAC design, that process, and how HVAC design can in the residential world exist as from a third party, and also have full commissioning just like the commercial world, and how you would end up benefiting from that. So some of our learning objectives today is the design process, defining commissioning, looking at it, the standards that apply to all those things, and then just talking about the commissioning process in general and how everybody benefits from it. The organizations that wrote the standards that we're going to be talking about today are on the screen there. I'm sure most people on this webinar are familiar with most, if not all, of these organizations. You have ACCA, which is the Air Conditioning Contractors of America. ANSI, you call them the standard guys, they're American National Standards Institute, and then Residential Energy Services Network, HERS ratings, and all things building and energy efficiency. They deal with standards for that. And then there's ASHRAE, the American Society of Heating, Refrigeration, Air Conditioning Engineers, which writes a very, very large amount of the industry standards that a lot of people, including all these other three agencies, piggyback off of and combine with to write standards. And then I'd be remiss if I didn't talk for a quick minute about National Comfort Institute. I wouldn't be standing here talking to you guys today for several reasons if they didn't exist. For one thing, towards the middle of my high performance building career, I started realizing that, after I had worked at a test and balance company for a while, I started realizing that in residential HVAC, airflow was the redheaded stepchild of residential HVAC. Nobody really talked about that. I ended up meeting Dave Richardson of the National Comfort Institute online. I started reading his blogs, and he's super knowledgeable about residential airflow. Like, he knew more than anybody I'd ever heard or talked to. And so he became sort of a mentor of mine. I reached out to him a lot when I had problems, and he always encouraged me to look at their organization closer. One day I was at a conference. Rob Falk, who passed away this past year from COVID complications, and Dave were given a session on residential airflow 101 and how it fit in. I sat in on the session. I was mind blown about the knowledge that they had from residential airflow. And so then I just started taking their certifications and joining their organization, and I learned a lot, and I grew massively in my career path and what I knew industry-wise from being involved with them. I can't say enough good things about them, but the point of having them here is the ASHRAE 221 standard would not exist without Rob Falk. It's literally as stated in his memorial that the NCI wrote there, his life's work, and it was his mission in life to make that as available to everybody else as possible. And sometimes at odds with his organization, who sold a lot and created a lot of this stuff and considered it proprietary information. And so he fought the good fight, and before he passed away, the standard did go into effect. So it's standard 221 is basically his baby. So I could not give him credit for that. So the first section of this presentation is we're going to be talking about the ACCA residential design process. There's a couple of these manuals and names of processes in this overall process that people are probably really familiar with. And then there's some things that they may not be as familiar with. Another great industry great that we lost this past year to COVID, Jack Rise, was the longtime instructor for the ACCA design process. When I took my original HVAC design for quality installation class up at ACCA, he's the one who taught it. And one of the things that he said has stuck with me over the years. It's one of the best things I ever heard anybody say about residential HVAC. He said the problem with residential HVAC is any damn thing works. And so what he meant by that is, yeah, you can get kids out of high school that go through HVAC class and get an EPA license, and they can put in a box that blows air, and they can make sure the refrigerant's hooked up the right way, and they can, hook some ductwork up to it and make sure that it doesn't kill anybody and it's going to blow hot and cold air. But that doesn't mean that it's installed in an optimal configuration. It doesn't mean it's going to provide optimal comfort, efficiency. It doesn't mean that it's not going to cause building durability problems because of the way it operates. It doesn't mean a lot of things. It just means the thing turns on and works, and that's the main. And the people in the residential world that buy houses and own houses have been conditioned to accept that fact that, hey, it's probably not going to work great in this room or that room, or we don't go in that room, during this time of year, and things like that. You hear about it, the same thing when it comes to building science and good buildings. You hear the same exact stuff. So in the HVAC world, the same exact way. You can build a building, that doesn't make it a great building. That means, anything built to building code is the worst thing allowed to be installed or built by law. So we all know that that's not really the end all be all of anything. So in this process, the three big guys, the three big dogs, we'll call them, are the ACCA Manual J, ACCA Manual S and ACCA Manual D. These are required by most code municipalities in some way, shape, or form. Every green building program that I've ever been involved with for the past 10 years, 15 years references these standards in some way, shape, or form. Everybody knows about them. You can see ACCA has a whole entire design process that includes these three things, but has a lot more to it. So they have their RS manual, which is a systems concept manual that pretty much talks about the correct design process from start to finish and how to formulate that. I didn't even know that manual existed. I've actually do not own it. I've read through it, but I learned all that stuff trial by fire. I really wish I would have had that in the beginning to reference. I wish I would have knew that existed. Then you do have Manual J, and then there's a system zoning manual in case you want to get into zoning your systems. Then there is the very, very important Manual T that unless you take the ACCA class, nobody's really going to talk to you about. But Manual T is the air distribution manual. It talks about all the things that nobody ever talks about, like where to put the returns and how you don't need a bunch of ductwork if you have a tight house, and register sizing and airflow and things like that. So it's actually, out of all the manuals, it was the most interesting one to read. It's not very thick, and I actually thoroughly enjoyed reading and learning from that manual because of the way that it's written. So that one is a great one to have on hand and to understand the concepts in. Then you go to Manual S, which is equipment selection. You have your Manual D, which is your duct layout and duct design. And then they have adjust, test, and balance, another thing in residential HVAC that you don't see. And that's NCI preaches test and balance in the residential world. They teach you how to achieve it, how to get your builders to achieve it. And, you know, it takes a lot of collaboration to be able to pull off a test and balance in a residential setting. It's a lot different than a commercial setting where everybody's prepared for you to come in and balance stuff. And even though that, you know, any balancer knows that that's not all rainbows and unicorns, but it is a lot more conducive to actually getting finished than a residential balance is. So that's something that's an oddball that should be looked at more, that it's not. Manual J is designed to be a software-driven calculation. So you do have to do it in some kind of software. The little quote that I have from Manual J says spreadsheet template or full featured program. I can tell you right now, the spreadsheet template is not fun, and it's pages and pages and pages and pages and pages long. So if you're going to use that, it's not going to work out great for you. You're probably not going to wind up with a very accurate calculation. From my perspective, the only real way to do a full load calculation is in an improved ACCA software. We use Right Software Design, but that is the list of approved software straight from ACCA's website that you could use to do the calculation. Manual J, just like any other calculation, any other software driven thing, anything that's math is garbage in, garbage out. So it depends on the level of the devil's in the details, as they say. Like you have to put in every minute detail of the house being built. You have to make the load calculation reflect the actual home that is being built down to the most minute detail. And these are both quotes from the Manual J book. I found them both very telling, you know, because we hear this crap all the time about safety factors and what if this many people come in the house at this time, and, you know, all these different reasons to increase the load beyond what it actually says it is. Well, ACCA tells you we have an appropriate safety factor built into the calculation. You don't need to do any of that. So it's been stated that the load overcompensates by 20%. I couldn't find that written down anywhere officially, but that is the general thinking, that there's around a 20% fudge factor already built into Manual J. So you don't need to create more. You're going to be way off if you end up doing that. And it tells you, especially at part load conditions, because these loads are designed and calculated for peak load conditions. So that's 1% of the year that these loads are designed for. Every other time of year, the house, home, and the climate is going to be operating in something under that, some different manner. So that doesn't need to happen at all. Like you really want to get it at optimal peak load, so then you can figure out the operation of the equipment for the rest of the year. Because once you've handled the peak load, you don't have to worry about that particular piece of it, and then you can think about how people are going to live in the home. These inputs are the biggest effect on the final load. Like these are the main inputs in the Manual J calculation. Okay, like this stuff has to be precise to the house that you're building. And you know, I hear people, HVAC contractors often say, well, we only do change out. I can't, the house is what it is. I can't do a good load calculation on that. Well, there's a couple ways to do it. One, there's another way to do a load calculation that doesn't involve manual J for an existing home that a lot of people, or not a lot of people, but some people in the high-end world use, which is monitoring the load for a certain amount of time and basing your load on the runtime of the air conditioner. So there's that way, but there's also a thing called an energy audit that we've been doing since the beginning of this, where you can go into the home and you can evaluate all the thermal properties of the home, how it's using and losing energy, and you can come out with a very accurate manual J calculation for an existing home and not a lot of time spent. I've done it many, many times, walked through with my computer, drew the home, put in all the thermal properties and walked out with a load calculation. Like, that is actually possible to be done. So either way it goes, either way you go about it, you have to have the information from the house, or else your load's created for something that you're not dealing with, a home that may not even exist, or not that home, or whatever, but it's not for the load for the home that you're actually doing the load calculation for. So this stuff all needs to be a couple of them are like the design temps. You should be using the ASHRAE 99% 1% design temperatures. If you're in an Energy Star program, they now have a little leeway in that. They've created their own variances for the design temperatures. But I personally, even when I'm designing in Energy Star, I stick to the 99% and 1% design temperatures. Like, those are the temperatures that you should be using. The same goes for the ventilation calculation, which I'll talk about more in just a second here. And then infiltration is another big swinger. I did a blog article quite some time ago that's on ACCA's blog about case studies when we use actual blower door numbers versus the default settings for manual J. And the differences are tremendous. You can be off furnace sizes and whole entire air conditioning sizes, whole entire furnace sizes by using default values versus using an actual either measured or predicted infiltration, ACH50 infiltration number. And if you're using predicted, there's a lot of things you can use to predicate that prediction on, like code for a lot of areas. There's 5 air changes or 3 air changes, depending on what version of code you're using. So if you have code saying every house has to be built to 3 air changes, there's no reason for you to design for something beyond 3 air changes, because they have to meet that by code to build their building. So that is something that you can dial in pretty closely to the house you're building, or if you're doing existing, throw a blower door on and measure it, and you'll have that. We're going to be using ASHRAE 62.2, some version of that for our ventilation calculation. If you're using good manual J software, that's built in. They have all versions, right? So you can choose what version of ASHRAE you want your ventilation calculation to be in, from 2010 all the way to 2019. Most of the time, you're going to be getting told what version to use. There's either going to be a jurisdiction having authority that's going to have a certain version of ASHRAE that they're on and they're using, or the energy program that you're participating in. Energy Star has their own idea what you should be using. The lead has their own idea what you should be using. So there's different versions out there, and depending on what program you're playing in, you may be tied to one of those versions of that ventilation calculation. But whatever version of ventilation calculation, ASHRAE 62.2 you're using, that should be calculated into your load, and that's going to be put into the load or factored into the load based on the kind of equipment that you're using to produce that ventilation. So there's different impacts on the load calculation depending on the way that you're providing the ventilation. So if you're doing something that connects straight up to the whole house system, it has a different impact than something that's independently ducted and not connected to the whole house heating and cooling system. So there's different, you have to be very precise when you're putting that in your load as well. When we boil it down to brass tacks, the consequences of a bad load calculation are very simple. There's 2 direct outcomes. You either have an undersized load or an oversized load, and neither of those are great. We're looking for the actual load of the house that is actually being built, or the area, or where the zone that the piece of equipment is being put in, or what have you. If you look at my list of consequences there for oversized equipment or undersized equipment, you're going to see a lot of equivalencies. The same thing happens on either side of the board. You can get poor indoor air quality from either one of those. You can get high energy bills from either one of those. You can get poor comfort from either one of those. So there's a lot of things, but If you look at the oversized list, there's some building durability stuff there that's happening from being oversized that you're probably not going to get from being undersized. So you're going to have short cycling, which is going to cause wet buildings, which is the water is the number one detriment to any built structure in the world. That's moisture and water. That's it. That tears buildings down quicker than anything. So that is a direct result of oversizing HVAC equipment. So that is why we need to be so precise with the load and our calculations there. Then we have the Manual S. Manual S is basic premise is not using nominal tonnage to size your equipment. So you're not going to say, oh, it needs 11,000 BTUs. This piece of equipment is 1 ton. That's 12,000 BTUs. I'm going to go ahead and put that in. You could be right. You could be wrong. It's going to depend on what that piece of equipment is actually doing at design temperatures based on the OEM expanded heating and cooling data that's provided for that piece of equipment. And nominal sizing is the same as garbage in. You use that, you're going to pay in pain. And I'm telling you that from experience. Like in my younger days, when I wasn't such a veteran in the industry that I am now, I sized and installed undersized equipment because I didn't know anything about Manual S. I just knew how to do a basic Manual J calculation, and I insisted on putting, and back at that time, even now, it's all, and if you're in the high performance world, everything's too big. There's no way it could be undersized. And so that's what you start believing that, which a lot of times it's true. Like there's a good thinking behind that. There's good experience. There's vetted data that shows us there's a ton of oversized equipment out there. But if you're not using Manual S to size your equipment, especially these days, because this new equipment is not getting nominal tonnage even out of the gate. Like if you look at what it actually produces, it'll say 1 ton and it'll say produces 10,500 BTUs or something like that. It's not a true ton of air like they used to. So even the modern equipment, nominal tonnage is not good at all to use. So there's a lot of stuff in this version. It was last revised in 2014 of Manual S that still applies. The base premise and the way that you would do your sizing and the process and all that is solid. It's just a little outdated because there's some houses that are built beyond the parameters of what that standard was written for, and there is new equipment that operates outside the methodology that's prescribed in that version of the manual. So they're in the process. It's in a revision period right now. They released a couple press releases. The wording in them are pretty interesting. This one said, I got it in bold there. Housing stock is constructed to be more energy efficient and requires less heating and cooling. Therefore, ACCA will consider this along with improved heating capacity of multi-stage and variable speed heat pumps, which allow them to provide heat for a whole dwelling. That quote came out in 2020. It's interesting because in 2019, ACCA released a supplemental manual called the Low Load Homes HVAC System Designed for Low Load Homes, LLH manual, and it addressed those things. It addressed low loads, buildings with 1,200 square feet per ton or smaller that needed some kind of a little more advanced sizing technique to get it sized right. Needed additional dehumidification to make it operate right. Like there's these things that happen in the course of low load buildings that aren't typical in a building that's not low load, and we have to be able to understand what those are. We have to be able to address those when we're specifying equipment in our design process. So this does exist, but ACCA has hinted around. I went on ACCA's website. I did not see this for sale on ACCA's website anymore, and this quote came out last year sometime too. They had a press release that talked about making Manual S super, and it's pure speculation on my part, but I have a feeling that they're going to incorporate the low load manual into the next version of Manual S, and that's going to be part of what makes it super. It's going to address everything the low load manual actually addressed. I don't know that for sure, but from the indications that I get from what I've seen personally, that's what I think is happening. Some of the things they're going to talk about, they said in the other press release, basically heat pumps that use dehumidification can be bigger. You can oversize a little bit more, and that's actually in Manual S right now. Like if you're using auxiliary dehumidification, there's very specific parameters for it, but you can oversize up to 15% more than what the allowance is in some cases if you're using dehumidification, using the Manual S the way it's written right now. So I'm sure they're going to build on that and go ahead and take it to the next level with these low load homes and things like that. And then we have heat pumps that allow you to have that don't use backup heat. Like I have a lot of designs installed right now where there's zero backup heat in, like we're using the heat pump only. And those require sizing a little bit different than what the current version of Manual tells you to do. You have to be able to size towards the heating load and also keep in mind what the turn down gets you. And then there's a balance point in between that where you can size that piece of equipment to cover the heating load and also not short cycle when it's in the cooling load. So that's a little bit of nuances that probably will be talked about in the new version. And then what you can do with dehumidification and then a little updating of the mandatory language. So I look forward to seeing that version of Manual whenever it comes out. I'm sure it's going to be great. And then we have the ACCA Manual D. ACCA Manual D is for duct design. It basically tells you to keep your ducts straight and rigid. I mean, that's really the premise of it. Like it's as simple as that when you boil it down to what it's actually talking about. Now, there's a whole bunch of math behind doing that because you got to get around bins, you got to get duct places. You have to be able to distribute the air evenly throughout the house. So it does take some calculation, but the thing to keep in mind is keep the ducts as straight and as rigid as possible at all times. Couple quotes from Manual D there. Load calculation determines airflow requirements. What's that talking about? Manual J. Equipment performance data determines blower performance. What's that talking about? Manual S. So there is a logical order of operations when you're doing this design stuff. It's JSD. That is the order that you do it in. You can't do it backwards. Can't do it middle. You got to do it like that for it to work the way that's intended to work. And they reiterate that over and over again in these manuals. And one of my favorite quotes, Paul the other day, I saw this in the slide. He said we should put this on our website and quote it from Manual D. It says, poor heating and cooling performance is commonly attributed to inadequate equipment size when the actual problem is a restrictive or deficient duct system. Surprise, surprise, surprise. Like that is something that we are going to, as we get down this commissioning path and this 310 stuff gets implemented more and more, well, that's going to be revealed a lot in a lot of houses. Like from my experience, I do a lot of high-end investigative type consulting things where I go to play houses and things that are having problems, and lots of times it is people think the system's too small and it just ends up being bad ductwork, or people think the system's too small and it's not set up the right way. Like there's a lot of everything. Everybody's been conditioned to say, oh, you need a bigger system. That's what even in today's world, as long as we've all been screaming about, oversized systems, there still is the common thinking as soon as something is not working right, it's automatically a bigger system. That's what people default to. So ACCA has been telling us for a long time that's not the case. You need to look a different direction. So what do your deliverables look like at the end of this process? Like, what are you handing over to your clients? Well, it can look a bunch of different ways. I'm going to show you a few things that we use. We also use different formats depending on the client, depending on the project. These are some of the most simplest ways to provide a thorough design package to your client. So we have the written equipment specification. Which can look something as simple as that. This is the format we use in-house. Like it's created in a Word document. It lays out exactly what piece of equipment's going to be installed, where in the house it's going to be installed at, how many of them you need, what zone it's serving, and also what the design parameters of the design were used. Like, is it a program? Is it code? Like, what are we designing to? And then also what the main equipment being used is and how many zones they are. So this piece of paper here, I have gotten the most compliments on this single document than anything in our design process. Like when people are taking this stuff out the bid, they love having this thing in their hand. They can hand it to the HVAC contractor. It doesn't have their metal in it. It doesn't have some of their equipments in it, but I do put the controls on there. I specify controls in all of our designs. Like we do that as a practice, because one of the most important pieces and overlooked pieces of any system is the controls. Like the way it's being controlled can cause the thing to seem like it is complete trash if it doesn't have the right controls on it. So you have to be able to specify exactly what controls are going to be used for that system and how they're going to be used. We put our dehumidification on there. We put our ventilation on there. Anything that's going to be used equipment-wise in the system, we try to put on this specification sheet. Then you have the next thing, which is, where'd my mouse go? There we go. Some kind of instruction sheet. Now, this can be if you are producing a plan set, and if you've ever looked at a commercial plan set or even like a residential multifamily plan set, they have the schedules sheet and they have the instructions and specification sheet that's in that plan set. If you're not using that format, which a lot of people don't, especially if you're using a residential design software, then you can create something that has all the instructions needed for that job. This is not all the information that we would put in it, but this is probably the least amount of information that we would ever put in one of our instruction sheets. So this shows your airflow settings, where the return is going to be connected at, your filter size, your design static, your design airflow, what speed tap in that air handler or furnace should be set to achieve that design airflow, and any kind of information about duct takeoffs or duct fittings that may be the same for the whole entire job. Like if it's going to be a common fitting or a common takeoff thing that you're using, you can put that in there, and your ventilation settings. At a minimum, that stuff should be in your instruction sheet. A lot of times it gets way more detailed than that because of ventilation equipment we're using, and all that stuff. And we always do provide all the submittals for every single piece of equipment too, because there's a lot of information in there that the contractors find valuable that they can use. And then you have your duct equipment and duct layout. Your duct equipment and duct layout is a scaled 1 or 2 line diagram graphic showing equipment placement, duct size, length, register placement, grill size, and placement. And so it can be as simple as what I'm about to show you right now, which is what RightSoft produces. It can be a 2-line. We have the 2-line we use a lot. So this is, I'm going to show you 1 line, but there's also 2-line ducts that you can actually draw with RightSoft. And then you can use CAD based programs, and you can overlay your ducts right onto a layout if you want. Sometimes it's necessary to do that, especially in complicated architecture that RightSoft can't handle. For the purpose of the duct layout, you've got to be able to show that somehow. So you can use it, overlay it on CAD, and do it that way as well. And so that this here one looks like that. That's a very simple 1-line diagram that shows where all the equipment is, what the duct sizes are, what the pieces of equipment are. And I like to put the little load chart on the pages too that show what the load for that zone is. And that's something that you're going to have to make a template for. That doesn't come default with the RightSoft stuff. And then the last thing is the load documentation themselves, the manual JSD documentation. You should be giving them that. At a minimum, these 4 sheets should be handed over to them. A lot of times they're going to need or want a lot more than that. There's hundreds of pages that the software can produce. This is the basic thing that you're going to want to provide. So it's basically the load short form or the airflow detail, the room for room airflow, the project summary, the manual S compliance report, and your duct system summary, including all of your pressure losses and available static and total equivalent length, things like that. So that is what, from a design standpoint, we want to be able to hand over. Now, what are you giving your rater or your commissioning agent? Which a lot of times you're going to find out, like the raters are going to be commissioning agents in this format that we're using here. We, as a company, have chosen to create a network, use Paul's existing network through Green Building Consulting. He has raters in about 18 states right now, representing about 18 states. And we have relationships in many other states of that we can reach out to if we need to. And with everybody getting trained up on ResNet 310 process, it was an easy connection to make where we can say, hey, we have this design, here's our design parameters. We want you to go and verify the design once it's installed. And that's something that is very easy for us to do and provide as a service for our clients throughout the country. And so far it's been worked out pretty good. And as you're going to see a little later, like the commissioning reveals a lot of stuff in these installs that you're going to get blamed for as a designer. So it's been a win-win. Your design report is one piece that they're going to need. That's going to lay out in simple terms what the design is. Now, you could give them the same design package that you gave your client. That would probably be okay. They might have to sort through it and pull some information out and things like that. Or you could create your own custom format, or you could use the formats that's provided for you. Energy Star because of the creation of ResNet 310, created these forms here that detail every single piece of the design, because that design is going to get reviewed by the raters as part of the 310 process. So this stuff here, as far as RightSoft and Elite software goes, those two I know for sure. This will print out already populated. There is some fields that you have to fill in, very few, like the client information and some other stuff like that. You do have to go in and complete it, but for the most part, this is going to be populated as long as you did a good JSD design. And every bit of information from your design that you would need for commissioning is in this report. So this is an easy thing to use as a designer. You don't have to be a HERS rater to use this, because this is in it's available in RightSoft as you buy it. So it comes with that every time it's in the 310 supplemental report. The 310 report's been in there for a couple versions now. The 310 supplemental report just became available in the latest update of RightSoft and Elite. So that supplemental report that puts in the rest of the design information, you were having to use the old Energy Star design report for that piece prior to this, but they finally got the supplemental in there. So that's now in there set and available in RightSoft and Elite. And it will populate for you, and you can print it out and use it as part of your commissioning package. The equipment submittals are super important for the commissioning agent to have. They have to have that. They have to know how the equipment is supposed to operate as far as efficiencies and BTU output and things like that. And there's a ton of other airflow information, static information that are in those sheets. So it's super important to provide the equipment submittals for that. Some manufacturers do a really good job of getting you actual one-page submittals. Sometimes you're going to have to search for what you see there. The product data packet will take the place of the submittal if you can't find the submittal. So one of those two documents need to go for every piece of equipment that you are specifying. And then last but not least, again, the layout should be provided. Whatever your format of layout you're using, that should be provided to your client as well. Okay, so that is the design process. The next thing I'm going to move into, I'm going to give you a little definition of commissioning and talk about that. Then Paul's going to jump into the 310 stuff. And then we're going to jump into ASHRAE 221. I'll be talking about that and some of the formats that you can do reporting and measurement in. And then Paul's going to wrap it up with talking about the benefits that all of this commissioning provides to builders, contractors, and some other financial opportunities that are attached to it. So before we jump into the commissioning, I did want to I see there's 13 questions here. Brett, did you want to?
Well, so just so you know, it is 1:45, and it sounded like you gave us a pretty hefty agenda still coming our way.
Okay.
So
All
we
right.
actually might have to have you all back out at some point to kind of keep this conversation going. So I wanted to actually give Paul a chance to kind of go through some items, and then if you had anything more to finish out, and then we get into Q&A, if that sounds all right.
Yeah, that sounds good. We'll rock
Okay.
through.
Okay.
That sounds good. Thanks, Jeremy.
Yep.
And thanks, Brett. Thanks again for by the way, the first class platform you're always providing here at GreenHome Institute. So this is awesome. So you always do a great job help us get the word out. Always a pleasure. So 310. So Jeremy, you want to move that for me? So the 310 standard, the 310 standard right now is the collaboration of ANSI, ResNet, and ACCA, which is always hard to get more than one organization together and agree on anything, right? We've got 3 of them here that created a set of rules for HVAC rating. It was a big deal. And it was a number of stakeholder engagements and just honestly, it was a lot of digging in from a number of these organizations to find out where the failure points were. Where was that next right spot of performance that people needed to get out of the system? And we see that, in commercial buildings, leaving building envelope commissioning more to the end of it. And I think in residential, what we had is the mechanical commissioning side, right, was more at the end. And now they're seeing that's where the meat was. That's where the fat was, I guess, if you will. We could trim. So with that collaboration, it's a big deal, but they had to get the procedures, the tolerances, the protocols. They had to set all that up for this so that, home energy raters, auditors, HVAC contractors, that's who we're hoping delivers these. There's going to be consistency across the system. So I think you're going to see more and more of this training as it goes through. but the most important thing is who's using it or who can use it. And I think what we like to kind of give you as the framework at this point, this is what we see. Really, it's kind of two worlds. It's one, it's going to be for program compliance, right? Things like HERS ratings, Energy Star, the 45L tax credit, which kind of is now depends on the day, right? Changing some of those rules. And we'll talk a little more about those at the end, but those are a big deal because now you're going to be able to get more points, and if it's a HERS rating, right? Or you'll be able to get a higher and easier break to that threshold for Energy Star, or the 45L of the old rule and the new rule. And that matters more than most for those of you that are out there that are in the rating world or in the building world that actually use any of these programs. It may not seem like a lot in some cases. It may be 1 point here, 1 point there, but that matters on those margins. And in some scenarios where there's incentives and other things, it really matters. You start dealing with scale and you've got a production builder doing a couple thousand homes. That difference might be the difference between hundreds of homes at a couple thousand a piece for incentives. Green Building Consulting, we even put that in now standard. So that's our standard policy. We're doing this 310 we're going to talk about on every single HERS rating, every Energy Star, every Zero Energy Ready, LEED, Enterprise, National Green Building Standard, or Passive House. It has to. It's not a lot of extra work, but it's absolutely what the market needed. All right, what it is. You're going to look first for install defects, airflow and refrigerant charge. Those are the two big things we're trying to find, whether it's fan speed settings, right, components that are on the system that aren't working right, duct system install quality. Of course, we've done that in a lot of programs before, but that's not the only thing. The refrigerant charge, length, the change in height between the indoor and outdoor locations, the initial charge, and the airflow, again, those are all going to be factors that aren't being seen as transparently as need to be. This system allows you to grade that. Next. It does it in 5 ways. There's 5 tasks of 310. If you're going to complete this standard, you got to go 1 through 5, and each one, except for one, goes and everyone lines on the other one. So if you don't pass number 1, design review, all right, you don't hit those tolerances that are set for the design review, then you stop. If you do pass, the tolerances are met, you move on to stage 2, which is total duct leakage. Okay, you get a grade 1 or 2 there, great, you move on. You get a grade 3, you stop. It's not passing. And this is a good for those program world, right? Energy Star, HERS ratings. Those are going to be things that are now going to be either pass fails, or they're going to give, like in HERS, it might give a point drop. If you're in the commissioning world, right? So non-program, this is just, again, anyone that wants to diagnostically test, building failures right in the house, want to see what's going on with the comfort issues or other issues in the house. And they're using this as one of the tools in the box. Then they're going to go through and figure this out. It's going to be a good guideline, but you can move, the professional can say, okay, well, I'm going to go past this, even though this failed, I'm going to do these items. Third is the blower fan airflow, right? Grade 1 or 2 in the programs, move on. Grade 3, you stop. Now, the 4th one is blower fan watt draw. Technically, you're just recording that, but again, it gives a grade. 1 and 2 means you're in good shape. 3 needs something to definitely look at. And then getting into the refrigerant charge, there is no grade 2. It's either charged or not, right? So it's a grade 1 or 3. Next. So in task 1, when we're getting into the design, really what we're needing to do is, it's a checklist, right? You're just going, just like anyone has gone through and submit a design to a program world where someone's checking your designs for the items. That's what this is doing, but deeper. We now are going to be looking at those very particular items that do make a magnitude of effect on this design, and really does make the difference for ones who just put in a design that's just going to be rough, but really they're going to change whatever the spec is out in the field, to where this design is really going to drive for the right outcomes. And that's going to be everything down to floor areas, right? So the actual floor area per zone, there's going to be a threshold of plus or minus that you can stand in. The window area per zone, that is a plus or minus that you're going to be able to stand in. These are huge differences. Jeremy, I cannot tell you how many times has found a design when we wonder, hey, is this really, there's issues with it, right? And he goes back and he looks, those numbers were just literally just thrown in, right, into the design and really aren't even close. And there's a whole bunch of reasons for that in that process. So that's why it's better to spend this time at the end to check this. Internal loads, same thing, going to have to be within not only the occupants, but also, right, appliances. Those loads are going to have to be within a threshold. Indoor design temps, outdoor design temps, make sure you're hitting those. Insulation and window values, right? Are they accurate? Were there changes that happen in the middle? Look, with supply chains right now, if you aren't checking things that are coming to the site, and actually watching what's coming there, I mean, you literally might be flipping a coin on some items because there's having to be 7 or 8 changes we've seen sometimes on a certain product because things aren't available or that line is too long if you're trying to get a house closed. Ventilation and infiltration. These are items that absolutely make a big difference to this design, and you can put real numbers in now. On to task 2. So task 2, grade of duct leakage. Anyone doing, again, HERS and Energy Star and all that are used to this, but this is total duct leakage. This is a big deal that all the rest of the world is not looking at in a lot of cases, but this is going to be a major outcome, right, of comfort. Anyone that's ever really done a total duct leakage on an existing house that's never had a rating before, they will tell you that this always comes up. It's always that long throw, right, to some area, the air is not getting there. And that's the room that's always uncomfortable, right? Very big that we go to these thresholds. Next. All right, blower fan airflow. So what you'll need here, pretty simple, is one of a few measures, and a couple of these give you different options, but a flow hood, a flow grid, you've got pressure matching, or you got the static pressure table that you can do. I will tell you that, at GBC, we're going to be doing an HTP, we're going to do the flow grids. It's the most accurate, versatile. You should see them. They don't cost a lot to get out there. We highly recommend those. But passive flow hood's going to be able to work for you as well. It gives options, and I will say that a number of these, if your guys aren't used to maybe one of these techs, and these are not, nothing in here is that difficult to do. Nothing is going to cause you, once you get rolling on this part of the process isn't going to be 30 minutes or more. This is not a big ask, but it is just learning which one works for your company or group. Next. Scale. We won't go over ranges today. All right. For task 4, if we're doing our fan watt draw, you got options. You can use a plug-in meter in some areas, right? That you can do that. The clamp on watt meter is probably what you're going to see a lot. That's what we're doing. That makes sense. You can do the utility meter again. Highly unlikely that's going to be used, but there's some scenarios where that makes sense. And again, any of these are allowable to get this passing of the 310, but if you're getting in that 3 range, you're going to be really wanting to go on and look into it. Go ahead. And go next. All right. So task 5 is refrigerant charge. And again, another one where a lot of guys that are out doing energy audits or ratings are not used to standard, but there's a couple different methods depending on your temperatures, right? Your extreme temperatures and some of the mini multi-split systems, you may have to do the weigh-in method. Otherwise, this kind of non-invasive method process is actually very, very simple. It takes the tech kind of out of it and the fear I think that some of the industry had into getting into this. It's not just the 20-year professionals that can do this method. That's why this was a big breakthrough to be able to allow this testing for non-HVAC credentialed individuals. Yeah, next.
And that's it.
All right. So I'll turn back over to you for the 221 because that's the other half of this picture. And it should just take a second.
Yeah, just real quick, everybody, I want to let you know, for those of you who are here for your continuing ed, you are now approved. So if you do need to get going, you are welcome to leave if you've been here for the whole time. But we do have more to the conversation, so please do stick around, dive into the conversation. We'll get to some more Q&A later, but otherwise, thanks everyone for joining us.
Thanks, Brad.
All right, I'm going to back up real quick because I do want to make a point here from one of the slides that we sort of skipped. Just really quick, I want to talk about the levels of commissioning. So commissioning process is a testing and reporting process that takes place at the end of the HVAC installation, like we were talking about with the 310. That's a form of commissioning. Their levels of commissioning range from acceptance testing to verified acceptance testing with verified to meet project goals. Those two things together are probably represented by the 310. And then there's the crown jewel of the commissioning process, which is the system performance rating. That's probably the gold standard. If you have all three of these items in your commissioning process, that is what we consider a full commissioning process, and is what, when we say verified design, that's what we're using to create verified design, is that commissioning, those levels of commissioning. These are the elements of HVAC commissioning. The first 8 of these are probably covered in 310 in some way, shape, or form. The last one being the ASHRAE 222 that I'm going to get to. And the very last one there, ensure the building's performance is verified, I thought was very interesting. I found that in list of commissioning process over and over again. And that's just because you could have a great HVAC system, and if the building's junk, then the HVAC system is still going to get blamed for things that probably is not the HVAC system's fault. So it's important to make sure that the building has also been verified when you are doing your commissioning process. So we talked about the acceptance testing, or the 310 testing parameters that can be done as individual parts. And then there's this last little cherry that you can put on top. It's the field measure and score test method to field measure and score the cooling and heating performance of an installed unitary system. The purpose is exactly what the title states it is: to score a system, or to rate a system for the amount of BTUs it's able to deliver at prime temperatures, peak temperatures. Again, this is a little forward in the standard. It just says NCI has been doing this stuff for a long time. They finally gave it to us, and we're super happy that they did. So that's the long and short of that intro there. But 2001 is about when they started implementing these particular measurements. So there's 3 things that in the standard are talked about. There's cooling system performance rating, heating system performance rating, and EER on a cooling system. I'm not going to talk about EER, but you can certainly, because you're already doing watt draw, get that measurement very simply adding on to the 310 process the same way I'm going to show you how to do this. Now, in the 310 process, step 1 and step 2 are already done out of this 5-step process to rate a system, cooling system performance. Heating system performance is rated the same way, you just don't use empathy. So that's why I'm demoing cooling, because it's the most complete part of the process. Heating, you back one thing out and you still have the same exact formula. So with this cooling system performance rating, you're going to do everything we talked about in 310. The system's already going to be running 15 minutes for steady state. You got to do that to do the 310 testing. You got to have the system running, have to get it up to steady state. It has to be calling for high cooling. Like, all those things are already done. All the nameplate data gathering already done. Design already verified. Everything, every step of the way already done. Up to step 3. Step 3 of this process requires you to measure wet bulb at 3 central supply registers and 3 central return grills. Okay, that's something you're not doing in 310. So you're going to take those 6 measurements. It sounds like it's adding a lot, but it's not. It's so simple to do that when you do this during the 310 process. Then you're going to calculate system empathy. Doing that's going to be done. Either you're going to take your wet bulb readings and you're going to go on a psychometric chart and you're going to plot that out and you're going to figure out where your empathy is, or you can use a handy dandy empathy chart like one that NCI provides. If you are a member of NCI and you have taken their certification classes, they allow you to use this little chart, and it is a dream come true because you don't have to mess with the psychometric chart. You just take your wet bulb reading and you match it up to your empathy on your chart and you record that empathy. So once you do that, you then get your average supply empathy. You take the 3 empathy numbers, add them together, divide by 3, do the same for the return, and then you multiply or then you subtract the average return enthalpy from the average supply enthalpy, okay? And that's going to give you your system enthalpy. And then you're going to take system enthalpy and you're going to multiply it by your total airflow number that you already got from your 310 process. And you're going to multiply it by your BTU multiplier, which is typically 4.5, unless you're in a different height. Elevation is what I'm trying to say. If it's a higher elevation, that number changes a little bit, but it's mostly 4.5. And once you do that, that's going to give you system performance. That gives you the exact BTUs that that system is putting out at that exact moment, which should be high cooling, which should be your peak load temperatures, which should be your design temperature. So you're going to be able to take that number and divide the delivered BTUs by the design BTUs. Now, you should, in the standard, they give you a format for collecting this data and doing this. If you're a member of NCI, they give you this handy dandy little sheet to do the calculation on. It also makes a nice reporting sheet. And this is a real world example of a system. So we got called out. This is not a verified design. This is somebody else's design. It was an Energy Star design. They did it to the parameters of Energy Star and LEED. And then the lady, they installed the system and the lady called and said, it's too small, or it's not doing what it's supposed to. And the HVAC contractor said, that load calculation must have been wrong. That thing's probably too small. And so they called Green Building Consulting and they said, you guys are telling us to make these systems way too small. And so then we said, maybe we are. Let's send somebody out there. So we sent a rater out there. We had them do the 310 and do the 221. And guess what? They ended up finding out. The system is designed to operate at 21,740 BTUs at design temperatures. It was only putting out 13,632 BTUs at design temperatures. It was operating at 79% of its design capacity at peak load conditions. So we were able to prove that by doing the 310 and by doing the ASHRAE 221 calculation. So then once we did that particular calculation, let me get back out of that. My next slide here. Then we look back at the 310 and we were like, this is the great thing about doing this way. 310, the tasks that Paul talked about in 310 are indicators, clear indicators of where system failures are taking place. It's simple as that. That's why they don't let you go on from one to the other in the grading process, because if it's failing there, nothing else matters beyond the point that it's failing at. So they gave us that information. We did the process as part of the testing. And so this is the little, there's a data collection tool that Resnet has put out. This is the printout sheet from that, from all the different measures. And you can see there that we got the total duct leakage, fine. Got the blower fan airflow. Guess what? It's below the top of the grade 3 tolerance. It was a hard stop for the 310, but we went on anyway and did the process and got to the 221 and we're able to see, hey, it's operating at 20% or 80%, 79% capacity. And that is because the airflow is at 80% roughly capacity. If you do the math on these two numbers here, like it's rough, it's operating at roughly 80% capacity. So 28% difference between the design and the actual operating airflow. And if you look right there, it says observed fan speed setting 0. Guess what that means? That means that the thing was out of the box, set in the house, and that was it. And never got set up for the airflow that the design, the HVAC design said it should be set up for. So it wasn't producing the beat, because airflow produced the amount of air that it takes to get to each room that's calculated is really a function of the amount of BTUs in heating and cooling that need to come to that room. So the airflow wasn't right, the BTUs wasn't right. It's that simple. And that was discovered that they were right in a sense. It was too small, but it wasn't too small because the equipment was too small. It was too small because it wasn't putting out the right BTUs or the design BTUs that it should. So that is the value of this commissioning process. Now, there are other things that make a complete commissioning process that have to be done. OEM manufacturer specs for ventilation equipment, dehumidification equipment, anything that is specified and has a setup process. You're making sure that piece of equipment is set up the right way. You also should be collecting your static pressure drops during this. All of the entire airflow static profile of the system should be documented as well as part of your commissioning process. So this is another handy dandy sheet. National Comfort Institute provides if you are one of their members. This proprietary sheet, you can't use it unless you are certified through them, but I am, so I use it and I'm showing it to you guys. as far as collection of all this information goes, there is a great way to do it. You can do it using you go in the standards, you look, there's tolerances for the equipment. As long as your equipment meets those tolerances, you can use the equipment as long as it matches what they say you can use. Or you can get into the wireless world that's out there now, which is the way to go. You can do all this stuff at almost exact the same time. Like when we train our raters and our commissioning agents in home, like we have them get the system running to steady state, put every single one of your probes in place. Your duct testing is probably already going to be done, but your airflow can be measured at the same time. Everything measured goes into some kind of app. I have up on the screen here Measure Quick, because we've been working with the Measure Quick guys to come up with a nice little one-page printout from their app of every one of the 310 measures that have been taken care of, and also print out the score as a certified stamp on the system of where it's performing at. The other benefit to something like Measure Quick, and specifically Measure Quick, is that you can have one person go out, do the testing. Okay, they didn't hit it. Somebody else goes back out. They just open up the app and that data from the last test is already in there, and they start where that guy left off. So you don't lose anything. There's nothing left to chance. It's all held in the cloud inside the app. Also too, it's Measure Quick provides live QA for the client or program. So they can watch the QA, the commissioning process being done. It'll actually show them when the probes are live, what probe is being used, all kinds of information that you can get just by watching the process. And if it's somebody that's not quite sure what they're doing, you can make sure that they're actually doing it right. Or if you don't trust the person doing it, whatever the situation is, you have the ability to view that in real time as it's being done. So that is a great tool. I highly recommend if you're going to create a commissioning process, looking that direction. Now, this is our last slide of the presentation. I'm going to let Paul take this. He wanted to talk about this a little bit before we went. He alluded to it a little bit earlier, but I'll let him finish it out with this. Go ahead, Paul.
Thanks, Jeremy. So we like finishing out with the big why, right? So when you as soon as you click the log off button right on any kind of webinar, you always ask, why did I spend the hour of my life on that? So this is it. We want to know why this is happening and why the benefit to you, right, to whoever's doing this. And this is again why I will give credit to Jeremy and our teams to put these together. You're taking a 310, which is great. Thank you for all the organization putting that together. Taking the 221 together, creating actual residential commissioning, which again, those of you in the commercial world or dealt with it at all, it's a standard stuff. There's no way anything of any kind of performance would ever not been checked for most of this item. But in residential, we've just waited so long to actually check some of the most basic things, or to confirm them, right? And a lot of things were not getting checked. So the big why is simple. 4 major categories I kind of throw it in. Number one, builders and contractors, it's peace of mind. I do put this in the defense side and the offense side. Look, the defense is warranty, AKA warranty. It's what am I going to have to deal with later, right? I want to make sure that I'm getting right what I paid for. If I'm a builder, I want to know that I got what I paid for, right? I paid for this service, I'm getting it. Number two, is there going to be a problem down the road? So if I got this great deal on my HVAC bid right now, but it's going to cost me X down the road, I need to know that. So it's just reducing that, having peace of mind. On the contractor side, it's the same. They're putting their name on it, right? They're putting their name on the system. They want to know that, make sure that it's going to perform right the way that they installed it. So both sides. On the offense side, look, you also should get a benefit if you compete against somebody else. It's just like any other thing. You're gonna say, look, we guarantee our product and we put a third-party certification on it. So that's great. HERS and Energy Star and all these programs do that and have done it for years. But you can do this for any program. So if you're out there doing service work and you're doing replacements on boxes, and you're replacing a box on an existing system, you have all these other variables, and they're going to blame you for all of them, aren't they, later? So if anything else goes wrong, so you've been able to come out of there and do this testing as an HVAC contractor and say, hey, I feel good about this because I checked these items. That's a huge differentiation in the market. That can really make a big difference. And it's what the consumer actually wants. Number two, yes, it does make it easier for those programs. You can get easier for the 45L, the old and the new version. And Energy Star is going to get you just that one inch. It's going to be able to get you there easier on items. Don't have to have it, but it's going to get there easier. HERS, you're going to get extra points. If you're in a program like a LEED program or Enterprise Green or National Green Building Standard, it gives you points for how many HERS points, right? You get points there. So by association, right? LEED matters. LEED will take credit for that. Big one on number 3 is you don't need HQEDO anymore. For those of you that have tried, it's been a lot, right? So for those you HVAC contractors that did, this was a hard item for a lot of people to get. One, there was a cost to it. You had to re-up it. And so there was a lot of markets that guys weren't doing a whole bunch of Energy Star jobs, but just every once in a while, they weren't going to pay for it. And we had trouble getting Energy Star in those programs. I don't think that'll be as much of a problem with some of the new legislation that went through, but that was an issue for some. And that might drive costs back down for you. And then my big one, guys, is it's a contractor benefit. So for you contractors out there, you won't be the first one to blame now, right? You do this work, or you work with a rating company that does this work, right? On the jobs you're on, guess what? There's all these extra checks that got there. You aren't always going to be that first. Hey, remember, we commissioned this system, right? We went through this. I have this. Oh, okay, well then maybe it's not that, right? Let's go somewhere else. I think you're always going to be on the list, but man, this is a bulletproof thing that you've got, and at least a starting point too for what's next. Go back to the building. Now let's look at the rest of it and see where these failures are. This should be standard, right, for everybody, and it's taken a long time to get there. The last I like to leave with is there's no reason this should be an extra cost. That's my market opinion. That's my job in the world, is to see how the market moves in these things. This should not be an extra cost for anybody. This should be baked in and show who either the full service guys are, the high quality guys. But honestly, it should be the standard. It's not a lot of extra work to do, but man, it adds so much more clarity. And with outcomes on the HVAC systems being at a heightened awareness, and I think an outsized outcome, right? The humidity issues, condensation issues that are happening, everything is just getting tighter and tighter, and not just the building, but all the variances. And so when something's off, you can't just guess. You've got to have that information. And for the small amount of work this is, and what this should be standard for all houses, I urge everyone that can to make this part of a standard practice. If not, we'll be the only ones out there doing it. And I guess that's great too. But no, I really do. I want this to be the market standard, so people have this as their base expectation, all the way up and down the line. Let's make the market more transparent.
Cool. Thank you. That's it. That's all we got, guys. Right.
Did Brett say he might have had to go to it right at
Okay.
that?
Let's
So-
see what-
Oh no, I'm here talking to nothing again. The void. Do you all have some time to hang out and answer some questions?
Yeah,
I
absolutely.
definitely can. Yeah.
All right, cool. Well, we'll hang out for a little bit. Before we do, just again, a reminder to everybody, if you want to rewatch this, catch it or share it, catch the recording, you can subscribe to our YouTube channel and get an instant access once it's available. For those of you watching this in the future, not right now, on demand, please take the quiz with an 80% passing rate. You can find that quiz on our Thinkific channel, our USGBC channel, or whatever channel this might be on in the future. For those of you here today, check your spam at certs@gutenbergcerts.com, and you will receive your certificate hopefully in the next couple of days there. And as those questions are coming in, we're going to get to some of them. A huge thanks to our top tier sponsors, Mitsubishi, Rheem, April Air, and all those who allow us to do what we do, our board of directors, our volunteers, all of our nearly 250 members, and our executive director, Jose Reyna. I want to get to a couple questions, and we're going to send you, Paul and Jeremy, the rest of the ones we don't get to, so you get a chance to follow up with everybody. Rob, good to see our new board member hanging out there. A couple different questions here. One has to do with infiltration calculations when doing a Blorador test. He's saying uses the entire volume of the building. Manual J 8th edition calculates building volume using the above grade volume of the building. How are you adjusting the differences?
You can actually, the new version of Wright's Law lets you compartmentalize any section of the building that you want to, so you can actually tell it where the infiltration is happening at and how you want it to calculate that. So that has been a known problem, but there is a fix for that if you're using the most current version of the software.
Okay, great, thanks. Yeah, and I just on Blorador testing, you mentioned infiltration. So could you get back to, there was a kind of a question. The question was really about what is the air leakage standard, acknowledging the fact that it probably is different across several states and local jurisdictions where there are stretch codes. But what can typically people anticipate if they're working in multiple areas to expect if they're trying to estimate an air leakage standard? I'd assume this is on a new construction project where you just don't know. I think you spoke to it a little bit, but can you just speak to us a little bit on how you're sort of gauging that?
Yeah, it just really depends on the game you're in. Like, so if you're doing a code build house, I would first go to code and see if they have some kind of code requirement. If not, I would then talk to the builder and see how they build their homes and what they're doing. Because of my experience with green building consulting and the new construction world and the requirements from LEED and stuff like that, we've gotten pretty familiar with the way a building test out depending on what the construction components are. So we're able to predict that a little bit. So I do a lot of times use a predicted ACH in my design if I have that information available. Sometimes the program itself is going to dictate air change targets about what you need in the energy model and things like that. So it is a multiple faceted way to come across that information, but there are definitely ways to get pretty accurate with it and to make sure that you're giving someone a quality design based on infiltration and not guesswork.
Anything to add on what you all do, what you do, see, Paul? No, it's the same. You get the, once we have that knowledge of where they're going to come in. Yeah, it's easy to do, but you just got to have that standard, and you get that standard information. It guides you well.
Yeah. Question here from Brian Mitsubishi. Thanks for joining us out there. And actually, I really had this question myself and wanted to add a little bit to it. But is there any discussion among people to put these standards together to show the various BTU requirements at different design conditions instead of just the extremes? The reality is that we spend most of the time at less than the extremes. But I also want to add to that and say, we need to start planning for extremes coming quicker and quicker. They're coming faster and faster. It's getting hotter and hotter. And sometimes in the winter, it's getting colder and colder. So how do we, to kind of converse Brian's question here, plan for climate change, in our heat load calculation? So maybe try to speak to just sort of these constraints you have to deal with when you're trying to help people correctly size and plan for the future.
So Jeremy, let me just answer from my perspective, and then you can chime in. I say this because I'm the non-technical one, right? I'm the one that deals on that sales side a lot of times, from client down, and that's the big question, right? So how do you get the design of these systems? Like, one, might have been earlier, and some of our early Energy Star and lead homes of, man, I just don't know if I can feel comfortable at 74 degrees, right, or 75. And you're already getting over first that just idea, is it actually not comfortable, or is that just a number in your head that you've always had your things set at 71, but this house is tighter, more controlled, less humidity, right? So once you get past that, you're exactly right, Brett. What we're seeing is those outcomes now, the variances and the tolerances are so interesting, because everything from the tighter the house gets, we see the ventilation rate has to be more dialed in. And when that's more dialed in, these other outcomes are amazing. But when they're outside, that's a problem. So and then deltas between your temperature differential and relative humidities. What I love about it is this and I literally beat up Jeremy in this all time. Wait a minute, there's no way that you can't give the flexibility for this, guy that wants to do a custom house, and then he wants to add, he's got this third floor and he's got a stack effect. They're like, it's all in there. The whole system has all that liability. So one is auxiliary systems. There's a design parameter to add an auxiliary system for when you're going to have a party and you're going to have 50 people over and the internal load is going to go bigger. But that's not going to run all the time. It's going to run on those extreme events, right? When the load goes crazy, or it could be on the day that hits 104 in your area when you're not used to it. That's okay, right? But that's an auxiliary system, and there's a very exact definition for that. And so that's missed. The variance, the other big thing is once you start controlling for the other factors, that's what amazed me, is that those design parameters came correct. If you did not, though, Jeremy, when you started making higher efficiency units a lot of times don't push as much airflow. That's one of those things you kind of learn about. And so from your sizing standpoint, you've got to manage that airflow in other ways. Your ventilation matters so much more, because they aren't going to send these long, crazy runs, right, as easy as they did before. And that was getting people confused, I think, a lot on the design. They were mixing up these two variables, and that's what, it's never going to make it. When you're half true, half right, that's why all these programs are, as a system, you start going back, why did they care so much about ventilation? This is why, right? And so you start seeing that the ventilation actually is going to move the body around, move that air where you needed it. It also comes back to, did you design it right? Like a central body with really long runs, like, were you thinking like that, or did you go to, right, zone systems? It matters a lot in that process. If I missed anything, Jeremy, but that variability is there.
One thing I'll say, this is like a little key phrase that I like to say. I look at the latent load first in the home. Like, we control the humidity first. Once you control the humidity in the house, then you can do a whole bunch of other stuff with the equipment. Like, as long as you have that dehumidification and you have the auxiliary dehumidification and you're demanding that in your designs, which I don't sign off on a design if it doesn't have auxiliary dehumidification and a code built or higher performing home, like modern code and up to Energy Star, LEED, badass home, passive, whatever you want to do, you've got to have the auxiliary dehumidification in there. And then your world opens up to what you can do, because once you're controlling the humidity, there is a bunch of different tactics that you can use inside the actual design that will allow you massive diversity in the house as far as the types of equipment that you can install, variable speed heat pumps, 2-speed heat pumps, things like that. And especially with the inverter stuff, where we can actually put one box outside and have a couple different zones in the house and have central dehumidification somewhere. Like, that is the way to handle that part load stuff. Look at the humidity first and then get into sizing for the part loads and figuring that process out.
On that note, with humidity sizing, really interesting to me. And how much do you factor in the building shell and what kind of materials, whether they're permeable or impermeable, or a lot of people are moving towards, basically breathable systems, right? So they're not leaking air, but they're allowing water to move in and out. How much is that factored into when you're planning for humidity design control sizing?
It's factored in a little bit, but the great thing about auxiliary dehumidification is it's a super big band-aid solution to a lot of stuff. So, like, you don't really have to worry about it that much once you put the dehumidification in. That's the point of it. Like, is it going to matter? Do the building materials matter if you're maintaining a relative humidity set point of 50%, 50 to 60, depending on what the comfort is, 45 to 60. Some people say, like, depending on where your range of comfort and health is in the home. Like, no, it doesn't matter. Once that is maintained at all times, you're living in a whole different world when it comes to building materials, HVAC equipment, all that stuff. It's such an easy pivot to do that one thing. And then that's what I'm saying. Like, then there's a whole bunch of other avenues that open up for the way you can build the house and the way you can design the system and stuff like that.
How are you accounting for, some of these sizing software systems for matching AHRI data? I know that is very important. It's required for the certifications. And concerns about, these platforms not getting newer technologies like ground source heat pumps, aka geothermal, or cold weather climate air source heat pumps, correct?
Well, AHRI is a fickle beast. So they're If it's, yes, it's required for compliance with Energy Star, but Energy Star also knows that you're not always going to have that data available. So it does say OEM stated specification can be used as well. And so a lot of times that's what we're doing. We're digging through the manufacturer printed data for their pieces of equipment, the expanded heating and cooling data, and finding that stuff and using that as a statement in our submittal to Energy Star to go ahead and say that that's the way that we're certifying the performance of the system.
Anything to add to that, Paul?
No, but again, just I'll say with a lot of going back and data crunching, is that was something that was probably one of the more found items in reviewing designs, right, for programs that were just automatically assumed, of course they're matching, and we're not, right? And that was something I think when we elevated our design depth, we were already doing a few years back, that we probably saw those matchups not being there, and the real performance not being what they said it was. That was a big deal. So I don't know that, I think that's still an industry item that's not being reviewed as much.
Yeah, good point. So this 310 standard, when it came out, I thought the same thing too. The raters, HVAC aren't going to do this. They're too busy. And this was, right as the pandemic was hitting, and then everything else. And we're just like, no, this, they'll never do all this commissioning. So it's got to be the raters. And then the raters, from my perspective, pushed back and said, we don't want this liability. We don't want to do all this extra assessment and then be blamed when the system doesn't work. But Paul, it sounds like you guys got it figured out. What do you say to the raters who are telling me that they're afraid of the liability?
Don't be scared.
Yeah. I remember I come from a consulting background in the financial world. So, I had everyone's entire retirement and wealth, on my shoulders at all times. So I'm a firm believer of being very, very clear about what the standard does, right? And if you feel good that you stay within those, and the standards built well, these standards are built very well to protect all parties, right? Like, follow those rules. And what you're doing is you are giving guidance on this standard that can be used. And now it's a true national standard that can be comparative. Are you saying it is perfect, or it is, all, 100% bad? You shouldn't, be careful of your words, play attorney in a second if you want, but what you are doing is, that's what's great about standards. Standards allow you that protection. That's your vest. That's everyone's vest. That allows them the comfort of saying, look, it's not just my opinion, right? I look at the steps, right? We did these testing. Here's the outcome. Now, one of the biggest ones I think we did, there was two major ones. One, I wanted to make sure, were any of the processes something that was so outside of, right, the rater's skill set, that they were going to have to be uncomfortable. And there were some good conversations. I mean, there was conversations around electric, like, that's something that a lot of people are, I grew up with electric engineers, my dad, so I wasn't scared of that, but I'm scared to death of water. So you get me near water and it's going to keep flowing if I screw it up, right? So, but people being scared of, right, of the electric side, that is a perfectly valid piece. So looking at clamp meters, right, that are a nice rubber, like, you're just clicking on the end, and if you've ever used one, like, there's no fear of you getting electrocuted from a clamp meter, right? You're staying outside the box. You're not getting in the box and everything. So things like that, that's a big deal that I wanted to make sure that the various skill sets, across the rater community weren't putting themselves in a position of liability. And I feel very, very comfortable about that. But that took some time to have those conversations. Other than that, just remember, it's the beauty of staying in standards. If you're out being an independent consultant, making up your own rules, then okay, right? Then it's all on you, right? If you're right or wrong. But stay within the standard, and you've got a lot of comfort there.
Yeah, great. Well, we are definitely at our time, but I really appreciate you both hanging out and educating us and learning more from you. It seems to be in the chat that everyone has stated that you have to come back on the show and spend a lot of time answering questions. So let's sync back up after this and see what else we can do. But it's great to see that people want to keep the conversation going. And just before we wrap up, and I'll start with you, Jeremy, and then give you the last word, Paul, where can people go to contact you, learn more, or work with you if they want to get a project going?
Well, I think a lot of folks on this webinar today are here from LinkedIn, so that's definitely one place that you can connect with me and our company always and in perpetuity. The last slide has our info at HVAC Design Partners email address on there, so you can contact us there, and the office numbers on there too. So any of those ways that you want to reach out to us, we're available.
All right, and Paul?
Obviously agree. LinkedIn, our websites are there, and I'll kind of say this as well, just like we have done with Green Building Consulting and HVAC Design Partners with our partnership to do that together. I suggest the same with others, because it works so well, right? Covering both sides of it, getting that commissioning side on one end of it, getting the design review on the other, and it's amazing when I did it because I threatened everybody I was going to do it, and that's Jeremy was my own threat of doing really good design in the beginning, and then now being able to commission it at the end. It's again the expectation of the market, and it's cool to be able to deliver it. So,
Paul, Jeremy, thank you so much for your time. Thank you all for joining us. Have a good rest of your week, and we'll catch you next Wednesday. So take care.
Awesome.
Got it.
Thank you very much. I
Take care,
appreciate
guys.
it.
Thanks, everybody.
Thank you.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.